Hello. Did the stream recover? Yes. Okay. Well, today I plan to do the work that I didn't do yesterday, which is test the mesh decoder against the reference implementation. It is hot in here. I'm gonna go open a window. Oh, I want to go back to the other song. Love this one. Hello. Doing CSGPHS8 today. Okay, here's the plan. We're about ready to rock steady. I am going to write down the thingy here. With my amazing skill. Okay. This'll work. This'll work. I can do it like this. Yeah. Normal songs. Um. Surely. What has happened to RSurf? Roblox happened. It's Roblox's game, not mine now. I mean that in a snide way. Like, it used to be my game, but now it doesn't feel like my game anymore. Is it gone? It's moderated. So, Roblox, but this is what I assume happened. Some automation tool was like going game by game and checking things, and then flagged my game, and now it's gone. So I've sent a moderation appeal to Roblox, and it will take 2 to 4 business days to process the request. What? Okay. Close everything. Where's the thingy? Okay, close everything. What if they decide to delete it forever? I don't see how that could happen. It certainly would destroy my life and many others. The game's been taken down 4 times approximately before over the course of 10 years. One of those times was 2 months ago, so it's getting more frequent. I think it's just turning into YouTube, where it's just too big for people, so you have to deal with robots. Bots just mow you over constantly. Ugh, okay. What does this do? Oh, it doesn't do anything. Oh, result. Okay, bud. Okay. Hmm. I suppose this is a while lap. Ooh, ooh. Debug, we'll need that. Bop, that's right here. Alright. Symbols. Alrighty. Righty, righty, righty. Yeah, whatever. We'll just keep it like that. Okay. Right. Yay. Okay, and then symbols. There you go. Okay, decode symbols. Hooray. Okay, so this says false, true. I don't know. But the worst thing that can happen is that left and right are switched. I'm pretty sure my symbol decoder... I'm not actually that sure. Because, like, it could be, like, doing, like, little endian, big endian swap shenanigans. Oh my goodness. Okay, so... Let's go to the test. Number 15. And do... symbols. Like that. Decode and test symbols. And snapshot. You know, yeah, it's fine. Okay, so now we go test. No. Boom, 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 boom. Alright, and there is the old symbol list. Okay, and then on my other branch, I do the same sort of idea. Yeah, bud. It's gonna be quite similar. Oh my god. So it's gonna be like this. And then it's gonna be no, 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 no. No, 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 no. Alright, is this... Yes. Okay. Symbol reader. Read. Indeed. Read indeed. Is there one error that can happen? There is. Okay. That's a lot like an iterator, but like, whatever. Just smack it. There you go. And what do you want? Expected use size. Okay, bud. There you go, bud. Okay. What happened here? Mesh. Friggin' yeah, man. And then oh. Well, that's sucky. I'm gonna have to do this one first. Come on, bro. Okay, so now we have these two symbol snapshots. Huh? Symbol snapshot 8382. Wait, what? Alright. What? What? Where's number 3? Huh? Snapshots number 3. There is no number 3. You gotta do it, brother. Oh, it died in the middle. My God. Okay. Alright, how do I fix this? Where's the thing? There you go. That's what it needs to do. Okay, okay, does this work now? Am I allowed to see this? Okay, so this is just totally wrong. Fair. Fair? That's fair. That's fair. Well. Mm. 1 bit. Okay, so it's just finding the gubba and it kind of looks like Roblox wrote this wrong. Classic Roblox. Ugh. Plus equals 1. Most significant bit first. How does that work? So we're reading Little Endian, and then it takes the most significant bit. There's no way. Well. Bum, 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 bum. I need to make this new up branch. All right, so the BitReader is a different implementation than Roblox, meaning it's not going to decode the same way. So we have to implement all the same quirks, which I can't say I'm excited about because this is quite nice. This reads in a consistent order no matter what the cache size is. You can change the cache size to byte, 16 bits, 32 bits, 64 bits, 128 bits. I haven't tried that, but should work. Why don't we try it? Should just pass. Cool. So you can just change the cache size, the internal type. No problemo. Wait, could I do U size? I probably could. Ooh, wow. Wow. And then we compiled a different code on different platforms, but it works any size. Cool. Because like all of the other types are sized with the platform size. So like pointers are 32-bit on 32-bit platforms, and U size is 32-bit. And then these are also 32-bit, but then this one's a U64 sticking out like a sore thumb. So what I think is happening here is I need to read big endian and then also start with the high bits. Because like this is starting with the low bits, I think. So shift left value bits. Mask draw bits. So how many bits are we drawing out of the cache? I'm not excited about this. This is a perfectly functional machine. So yeah, I wrote this test. Where is it? Clear symbol right here. To verify that it's doing exactly what I expect. So it's reading from the least significant bit up to the most significant bit. This way. Apparently that's not what it expects. Is there a difference between little endian, big endian for 1 byte? I feel like it only affects the byte order, and like the endianness within the byte is just opaque. Like it actually just doesn't matter. All right, so what I need to do is switch it so it goes the other way, which is also useful, I suppose. Well, actually, I don't know for sure. So this is the one we don't want. This is the one we do want. So we have to do the reverse of this. So it should say continue split right, but it says continue. Split is the second instruction. Good gravy. What is Roblox doing? Roblox. Little Indian. Surely I can just mask off the bits, right? So in the little bitty reedy guy, we're generating a mask. Bits minus value bits, draw bits. So move up. Okay, so let's say the bit, how many bits we want? We want 2 bits. How many bits are in the value? 0, let's say. So we want to draw out 2 bits from the cache into the value. So what does this do? This takes 1, shifts it left by 2. We now have the value 4. And then it subtracts 1, giving 3, which is 1, 1. So that's a mask that has 2 1s, and it's sitting at the least significant bit. So we're drawing 2 bits from the least significant bitty bits. From the bottom. So value gains the bits from cache. But it goes on top of the bits already in the value. We want to draw bits out the other way and put them on the bottom of the value. Is that only here? So this is putting all bits up on the top. Put those bits up on top. Chunk. But we want to Swap it around. This sucks. This is a well-oiled machine. It's got nice, readable code. Kind of readable. I'm using the chunks exactly like I want. Oh, man. I'm crying. My BitReader is wrong way around for Roblox. It's perfectly working exactly as I intended. What is it, Lee BitReader? Lee. So if we look at this, this is half of the number, and this is the other half of the number over here. Okay, let's see. Exactly 3 right there. So this is a U16. So this is the least significant byte. And then this is the most significant byte. As a byte slice, it's the other way around. So these bytes are 190/40. This is 40. This is 190. So writing it as a U16 little endian. Why does it say big endian? Our CPU's big endian. Yeah, I want to know which ones. Yeah, I understand that. Which ones? Which CPUs are big endian? Does anything use big endian? The IBM are big endian. Sounds like nobody's big endian. All of the computers accessible to me are little endian. Okay, this is what I thought. Just trying to confirm it. Why does it have to be so hard? Endianness. What's your endianness? I have to actually do it. I'm tweaking. So this, what is this? This is a Lee BitReader. Abba Gabba Ding Dong. Okay, so Why don't I make a thing for fun? Cargo new bit reader. That'll be fun. So we saw reader. We saw bit reader. Oh my god, bro. Itty bitty bitties. Little itty bitties. I just had a good idea. The chunks exact thing, shift it over and do the remainder first. Fill the cache with the remainder to start with in the constructor. No, it doesn't work. Well, no, it does work. Total bits. Total itty bitties. My gob. Alright, let's look at this code again now that I have written my own. I did look at it. Library. Uh-huh. I think my bit reader is better. Alright, where's the thingy? Read. Read. Brother. Mine is way better. Okay. Okay. So yeah, I'm just gonna yoink this, and then, is there bit dash reader? Bit underscore reader? Bit stream reader. Reading bit. Alright, how's this guy look? Icewind! I know this guy. Oh. Treat! Not the treat! Unsafe! What are we doing? Unsafe trait end bool underscore. My guy, please. What is that? Oh. Boom. Boom, 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 boom. What are you doing? Like, I understand, like, read float and stuff. That does make sense. All right, should I call it BitReader Lee? Or Lee BitReader? Or BitLee Reader? Uh-oh. So I'm trying to think. Oh, we lost it. Hello? Game? Hello? Bruh, what? Huh? 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 Okay, there it is. Well, okay. Alright, we'll start with this. I want you size. I want you. Use bit reader Lee. You good, bruh? No, mod. So what I'm thinking is, what if the bitty no ready is, it can be like wrapped around this? So instead of having it need the bitty bits in the constructor, it just implicitly has like a total like a length thing, and then you can like additionally restrict it Out of bits. It's out of bits. Yeah, it's not super nice. Like if you read a little bitty bits. How do you make it better? Better. Gotta be better. So I'm putting this in a separate thing because I think I'll need it for tray decoder. Okay, my little Lee BitReader guy. It's the same thing, except this is different. It has to smash cache onto value. I don't know. I don't know. Yeah, yeah. We'll put this stuff here. All right, buddy boy. Trying to think of how to make it the absolute best it can possibly be. And I don't think I have it here. I think that this I think this and this are necessary. I can get rid of this cuz like look, it's just there. It's just a little checker thing. Yeah, it could totally wrap it. What happened? What happened? Next, none. Right. So what happens is it'll just do this again and again, and it's bad. Oh, you know what I could do is I could replace chunks with an empty goober. No, I can't. Rem? No, I can. 0 rem. Interesting. And it would just read zeros. Do a 0 length mem copy. This uses intrinsics, right? Whoa. 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 Intrinsics. We love intrinsics. Okay. I think that is smart. So, yeah, I'm tweaking. I'm going to save it first. Open, open, topen, initial comment. Bow. Okay. Yeah, cargo test. Release. You know it. Hell yeah, brother. Okay. Ow, wow. And then yeah, bit counter. Bean counter. Counter. Similar. And then you go like, see a chump. And then see a chump. See a chump. And then see a chump. See a chump. And then this is not real. And then this is infallible. And then this go like replace the iterator with empty data. Self.chunks equals freak. Oh my god. It's like chunks exact. Oh, wait a minute. Can I do self equals? Not quite. Oh my god, bro. Yeah, array chunks would be better, smaller, faster, stronger. Array chunks. Okay. It's doable. Yeah, no, I could go like this. Yoink. Friggin' just new. Self new. Nothing. Oh, haha, XD, okay. Star. Just like that. And then spruce up the cache. We have emptied the remainder. Replace with empty data. Yeah. So, I mean, it'd be a little bit nicer to just do bytes. Right. Little bitty counter. Okay, so then what's up? What's up? Let's do that. It's maybe a little bit nicer. Yoink, sploink, chunks. No. Oh. Is that allowed? Yes, it is. That's kind of wild. Okay. We have a pointer to this thing. Okay. Okay. I want array chunks. We got array windows. We need array chunks. All right, new. Yeah, no little bitties. So there's no thing there. Oh my god, bruh. Oh my god, bruh. Oh, it's infallible. That's right. Homely momely. It just starts reading off zeros. That's wild. What? What? Is it? Okay, no, that's real. You good? So this is infallible. It just starts reading off zeros. If you try to read past the end of the... Oh. We could do like a debug assert. Yeah. So you can't read more than this cache size bits. Yeah. Type situation. Okay, how now, brown cow? Okay. What happened to all the other tests? Are we trolling? Wait. It's infinite looping. I see. Break, I guess. There you go. You. Nice. Okay. Move bit counter. Yeah. And then add it back basically. So then what do it would be like? Oh, do I need a trait? I do. So this is a bit counter error. Homely momely. Bit counter error. Wow. Trait. Oh, true bit stream is what I wanted to call it. Come on, bro. Game. Oh, oh, come on, bro. I was having fun. Oh my gabagoo. Why? Oh, true. This is so true. Name project. All right. Well, let me just write what I'm thinking. Think what I'm writing. Trying to think if I can use the same. We use counter for read and write. All right. Why don't I actually write it? He said. I cry. EOF. Indianness. Little guy. I'm thinking like binRW, where they have the readly and it just reads a struct. Do the same thing with the trait thing. The bitread trait was a good idea, but the implementation was whack. So bit counter. I actually have to write it. Come on, bro. Uh, uh, okay, there's two modes of operation, increasing and decreasing. Oh, the bits are going up. Oh, you're writing bits. Oh, they're getting written. Oh. I might be able to get away with both. Oh. Coastal office hours. Melt away. All right, let's write it for reader first. Just like prototype. Were these ripped from somewhere? Remember? Notices your flack. Yes. So I actually tried to buy this music, but Bandcamp changed their policy to disallow AI music. This is actually AI music. Don't you hate that it's good? I I want to hate AI music. Um but it wasn't available and I was like, all right. It's a secret website that just like grabs anything. It's kind of insane. Uh Root tracker. That's not a website though. All right, there's the thingy. Wait. Oh, I forgot to. Ooh. Okay, this is a bit counter error. Result self frigging yeah. And then none of bytes, none of bits. So like when you read, it'll be like whoa, read, whoa. Okay. Okay. Well, there you go. So that is the shrimple version. And then I think this is gonna work. Yeah, I think it's gonna work. So reader has this bit count limit. Writer, no. No. I think this is gonna work, man. Le bit counter. Uh, okay. No way, bro. Never used, never constructed, never used. Okay, bro. Pub type. Counted bit reader Lee. Wait, bit counter. Come back. Come back. BitReader Lee. Counted. Limited. Bit reader Lee with bit limit. Counted. Some of that. I'm gonna put away my coffee. I'll be right back. This is going pretty good. Go, bit reader, go! I'm just like having a good time here. There's got to be a better name for this. Okay. So traits. Yeah. All right. I'm going to do it. Should be like real easy. Like literally that easy. Value bits or bits value? All right. You know, those are pretty small. Let's put them right here. Nice. All right, and then this guy, instead of do like this, you go like impl for and that's it. There it is. We need the trait in scope though. What happened to the guy? Oh, there it is. What's buried? So cache buried. There you go, bud. Easy peasy. Yeah. And then in the bitty counter boy, it goes like impl BS. Let's call it S, I guess. Bit read for read. Are you seeing where this is going? Do you remember the old code? Where's the thingy? No. Frick. Do I need to type? There goes the simplicity. God damn. See ya. Error. So I could either have output type or error type. Could also have cache type. Unlucky, bruh. Bit counter error. My brother. So there you go, boss. Okay. Oh, how do you do this? Who did this? Checked sub. Bed count. Not quite, eh? Cause there's the inner type. This is telling me that it would work better like this. Output would work for both. Well, no. Yeah, that's what happens when you try to make your traits too general, too rust-brained, thinking too hard. Oh my god, bro. Yeah. So is this real? Yeah, no, it's not. Output equals result S output bit counter error. Output. Well, there it is. There's the bit counter. Bit read, bit write traits. No way. Oh yeah, the guy sent me the file on the thing. I'm the guy. I'm the guy. So this guy edited this to include the file. Put the file here. Put the file there. Here's the file. Here's the file. 312. I'll grab it. Okay, so nice. Counter. Lib. We can skip this for now. Oof. So this is a little bit sucky because it would be better to pass the Dinkelberg in here, like pass the bitstream in the constructor. Interesting. It doesn't. It doesn't actually read it. I wonder if that's unexpected. Okay, counted BitReader Lee. Because like if we have Lee, why don't I write it? Because like we're there. We can hold off on bit right. Oh my god. Holy. Bossa Nova. $56. So, yeah. Sounds like old elevator. Isn't it great? So I'm thinking re-implement chunks exact. Well, re-implement array chunks. So like, it's holding on to the remainder, but it doesn't need to. See, this is 40 bytes. It's holding on to the remainder and the chunk size. Neither of those are necessary. It can preload the cache on construction. I knew it. So it's not optimal. This is not optimal. God, I'm having a good time. Okay. It's gonna look a lot like this.
Chunks exact now.
Wait. Oh, len minus rem. First, second. Uh, how do you do the double man where it's like? I guess I can just do that. Yeah, I think I'll have my own thing, cause it's like chunks exact except skip the first thingamabob. The annoying part is that there's all this great iterator stuff. It's not quite array chunks. It's like skip. What would you call that? Like, it's kind of like alignment. So, oh, left pad, right pad. That's kind of what it's. So here's the idea. Okay, so you have numbers in a list. Whoa, and then it's. I want to take arrays of length 2, let's say. So in this case, it works. I've got this like arrays of length 2, but if I want, okay, let's say it doesn't work. Arrays of length 3. Boom, boom, and then I want to like handle the beginning remainder. So it's like array chunks aligned to end of slice. Array chunks align end. How do you pronounce quaternions? There you go. So it has to be like end array chunks. Kind of deal. Yeah. And then we go like I think I'm just gonna use the slice iterator. Oh my goodness. Okay, so this is like some crazy stuff. Hello, slice. So then we have const and usize. Chunk size. So we're gonna return 2 values. Probably I can get away with this. U8. Actually, T is okay here. T, capital T, and T. Boy. Okay, and then it's completely safe. This is totally safe. Okay, so Oh my god. So we're doing the big one. Slice.len divide by chunk size. So we got chunks and remainder. Split at remainder. Uh, um, uh, so what do we uh, if slice length is 0, less than or equal to, it's okay. No way. So then we go like, my brother. We're making a new slice. I forgot. Slice 2 raw parts. Raw parts. How do you do this? I guess there is no. Okay, whatever. Array chunks. Slice from raw parts. Slice as pointer, and then chunks, and that's 1, and then begin. Ooh, we guess we should do it like this, because this comes first. There you go, bud. Hello, gamer. Oh, I need a semicolon. What do you want? Pointer. Okay. Okay. You good? No. This is also wrong. Did Roblox do something with bhap? Maybe. Who knows? Looks like it's fine right now. Could die any second. You never know with Roblox. Why does this hate me? Chunk size T. Oh, because this is a T. Cast? There you go. Should we just say like PDR? So why is this one safe? We do a little bit of unsafe. Wow, wow, wow. Let's look at array chunks again. What did you say? Oh, we would need to look at array chunks. Nor array. It's probably nearby. Array chunks. No. New. Wow. Oh, it's Windows. Oh, there we go. Cast array. What's up with that? Cast from a pointer. Well, hell yeah. Is it? Am I allowed to use that? Unstable. Bruh. Alright, bruh. Okay. Alright. End array chunks is my little function that smacks them apart. Okay, so then. Okay, safety high. I guarantee that la 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 la, which means that la 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 cannot overflow, blah blah blah. Slice. Okay, why don't we look at the safety invariance for this function? How do you be safe? Data must be non-null. Valid for reads of length times size of t. And it must be properly aligned. Should be good on all accounts. Consecutive properly initialized values of type t. The memory reference return slice must not be mutated. The total size of the slice must be no larger than I size max. So it's getting smaller. Okay. I'm pretty sure this compiles to one instruction. And if it doesn't, unlucky. All right. Safety. Chunks times chunk size equals slice that length minus rem. Right. All right, so now I've moved all of the random stuff to compile time. So now we just get this slice, and it's 16 bytes rather than 20 billion bytes. What? Oh, chunks exact 40. No. So this is going to be a slice iter. U8 size of semicolon size of cache like that, and then watch this. Watch and learn. Let begin chunks is equal to end array chunks. Bytes. Then we take this, fill up the cache, it's like remainder type situation. And then we go chunks.iter. What? And then now in here, I believe we can do a while let. Oh, but it's draining the cache. Right. Dang. So this is just right there. And then this is a freaking array. We're just dereferencing that array. Very happy. So do not fill the cache. It's just going to return 0. So yeah, that code is gone. How fancy is that? You can't use Miri without unstable. How do you like use unstable for a sec? Without having to paste 3 commands. I just want to like use a rest use unstable environment variable. Rest flags. I don't want feature, I want environment variable. Pain. All right, let's see if I wrote terrible unsafe code. Surely it tests rather quickly. Yeah. Let's go. All right. Um. Um. Ingest remainder from beginning of slice. Well, isn't that lovely? Lovely? Simply lovely? So this should be the same behavior, but with less work. No more unwrap every loop. We just did a little bit, little bit unsafe. Just a little tiny bit unsafe. Oof. Just a little bit. There we go. So now this is 32 bytes instead of 64 bytes. It is half the size. Thank you very much. We're saving bytes. We're out here saving bytes. That's right. Is taken from the beginning of the slice. And this works with size 0, size length, that was schmort. Move it to compile time instead of runtime. This is a little bit sussy. We could do this. 0 underscore. That works as well. I think that might be a little bit more pretty. And what a... Oh, this doesn't happen anymore. Let's go. There's only one spot. Whew. This is const. Super cool. You love to see it. Okay, so that's BitReader LE. We actually need BitReader BE. So we're reading the slice bytes in order, but the Lee reader reads from the bottom of the each byte, whereas the BE reader reads from the top of the byte. So I'm trying to figure out how to like pass through the constructor in a nice way. Because like if you already have this S thingy, and like yes, the same struct can be used for reading and writing, but the constructor is going to be different. Yeah. So does this go in bit counter or does it go in? Yeah. It's just kind of a little bit nasty. Know what I'm saying? It should be nice like this. BE. Oh no. Actually I could do from bytes. That would work. Bits, bytes, bits, bytes. All right. I think I'll use from. I think it makes the most sense. Bits, bytes, bits, bytes. Okay. New. Impl from oh, is that allowed? Oh, okay. So then now I can do this in here, and we don't need any of this. S S from Bingus Bongus. How about that? Okay. There we go. Traits. Now it's nice. New reader. Yeah, it should probably be called new reader. Because we're going to need new writer as well. No way. And then that's not real. BE. Okay. Okay. There you go, bud. Very good. Okay, so use from trait in bit counter. And then BE for later. Okay. So this type 40 bytes. This is awesome. Okay, so now I have to actually write the big Indian guy. All right. So we put it on the other side, pick it from the other side. So this is value equals value shift left or cache. My brother. Surely not. Okay. Yeah, yes. So yoink it, then sploink it. So we're drawing bits from the other side. So cache mask shift. So that's adding it to the top. So it's like slicing off the top bits, shifting it, and adding it to the top of value. So these are not actually unbounded. They would fail if things happen. Okay, so I think I still need this mask. This does need to be unbounded. Why don't I fix the other one as well? So value bits. It can't. This can't be. This can't be. It can't be as big as the number of bits in the cache. Cache mask. Because otherwise you... Well, I guess it would draw bits 0. This should be like this, I think. I don't know. Is that a new project? A library for an existing project. I'm trying to make a really nice BitReader and BitWriter. Well, BitReader mostly. Look at this. So you have a counter that can count how many bits you've read. And then you just have like a raw reading thingy. So when you construct the new reader from bytes, it implicitly can read all the bytes, all the bits from the bytes. And there's this end array chunks thing. So you have like a list of values, right? It's a slice. And you're trying to split it up into chunks of 8. Chunk size is 8. But what I'm doing is I'm aligning the chunks to the end of the slice. So it's the last chunk ends at the end of the slice, and then however much is remaining is at the beginning. So you do division and remainder, and then you split at the remainder of division, and that's at the beginning, and then you have the rest of it. And so it constructs this like reference to a list of a slice of arrays from the input slice. So you get a slice at the beginning that's up to this size, well, less than this size. It's a 0, 1, 2, 3, 4, 5, 6, or 7 elements. And then you have a slice of arrays for the rest of it. And that gets rid of a bunch of code in here. So this is easy peasy now. And so the variable amount is handled right when you construct the reader. It populates into the cache. And then there's no special code while you're going through it to like, oh no, we reached the end and we don't want to yield any more bytes and it's going to have a problem. No, it just works. And then you read little itty bitty bits, little bitties. And everything is fantastic. It's so good. I'm trying to think of how to make this amazing. Like what I would want is to have while iter actually. Just freaking for loop it and then break. Yeah. So bits. So this is saying if the number of bits you want is bigger than the number of bits in the cache, then we have to put more bits into the cache. We have to like feed them from the cache into the value. And from the like source bytes, it's like going through, you know. But this is like not nice code. You can write this as while let or a literal for loop. For chunks. The problem is it has to do this first. I guess I could put it outside. But I also can't because it's an if statement guarding it. All right, let's just smash it into AI while I do something else. Maybe I'm missing something obvious. All right, so I'm working on the big Indian reader. The little Indian reader works real good. So I already wrote this code. So the little Indian reader is putting the cache bits on top at on the most significant side of the existing value. So that this can like actually this can only loop once, but technically if you make the cache smaller than the value, this is the correct code. But you know, it's fun to make fully correct code. So it takes the cache and puts it on top of the existing value bits, which is 0. And then writes over the cache. Wait a second. Yes, so this is guaranteed that the number of bits you want is bigger than the number of bits in the cache. So it necessarily eats the whole cache. Comment says populate. Yeah, I could use like mem replace. We are necessarily going to grab another scoobert for this doobert. Okay, so here's the part that I just realized. This needs to be like this. And now it's even more ugly. Because otherwise you're going to like repeat read from the end of the cache. This necessarily steals all the bits out of the cache. All right. Go, AI. Make this code more idiomatic and less cringe. Thanks. All right. Well, that's doing that. Let's go work on the BE. Okay, so how many bits are we drawing out of the cache? The number of bits we need minus the number of bits that have already been put into the value. So then we need to mask off the bits in the cache. Indeed, we need this mask. And this is taking bits from the bottom of the cache, the least significant bit first. But we want to take it from the most significant bit. Shift left, cache bits minus draw bits. Mask. Shift left, draw bits, mask. Where's this? Okay. Right. Okay, so this is a mask of ones. Draw bits, ones. So draw bits is like 2, let's say. We're drawing out 2 bits. Give me 2 bits. So this will be 1, 1. And cache is a U size, which is like a 64-bit number on 64-bit architectures. So we want to align the ones with the bits at the top of the cache. So the ones are at the least significant bit, and we want to up top. -2. Does that make sense? I think that makes sense. So then value or equals. I think we have to do 2 shifts here. So this is shifting the cache, but really we want to mask the cache. Cache. Mask. Shift left. Hold up. I think I can reuse the cache mask. All right, let's call it that. Let cache mask equals to Mr. Mask shift left by cache bits minus draw bits. No way. Boom, boom. Mask shift unbounded. It's not unbounded though. So the number of bits in the cache, let's say there's 7 bits in the cache. So we want to grab bit number 6 and bit number 5. So that's mask is 2 bits at bit number 0 and bit number 1. Shift it left by 5, which is 7 minus 2. Draw bits is 2. We're drawing out 2 bits. So then cache mask shift right by that would be it'd be easier to just shift right the cache and then use the original mask without creating a cache mask. Let's do that. So value equals value shift left by draw bits so we're moving it up, bumping up the bits to make room for 2 bits, and then now cache unbounded shift right by what? Oh, mask. We're just taking it off the bottom. Boom. Yoink. Yoink. And then... Is that true? Weren't we doing that before? That's not true. That's not true. This is a shift right. We're trying to add the bits at the top of the cache to the bottom of the value. So cache needs to move by cache bits minus draw bits. So that this number is 5. There's 7 bits in the cache. And we want the top 2 bits to be at the bottom of the number and then ORed with this value shifted up by 2. Yay! And then... okay. But the cache... No, we're taking off the top. There are no more bits in the cache. So we don't need to mask off the top of the cache because this is the maximum number of bits. We're taking it from the top. Okay. If you say so. Okay. So then now we need to mask the cache. Top of the... So mask shift left like this. And this is the opposite of the mask. Okay, so the mask is 2 bits because we're drawing 2 bits. So that's 1 1 at the least significant bit. And what we're trying to do with the cache is delete the top 2 bits of the cache. The cache has 7 bits, so that's bit number 6, bit number 5. So we shift the mask up by 5, and now it's aligned with this. do not, and now we have ones everywhere, except for here, which is zeros. And then we do and with our ones, and that deletes those two. No way. Okay, I think that's it. I think we have a BE reader now. This is wrong. Move it up by cache bits. Now the value has more cache bits from the cache. I do believe. Okay. So this stays the same. Wow. But now we read like... Okay, let's see. What does this look like? 001. Okay, so this is DSA, but we're reading A as D. Am I stupid? 001. What is this guy talking about? Why would it start there? 0, 0, 0, 1, 1. So this is saying 0, 1, 1, 1. You see that right here? 1, 0, 1, 1, 1, 0, 1, 1. That's what it's expecting. So it's reading chunks this way, starting from A. Oh, that makes sense. Okay. Okay, yeah. So it's reading right to left. That's DSA. This is D. This is S. This is A. So that does make sense. So it's starting over here at A and reading the least significant bit first in that order. And then if we do it the other way around, now we get A as D. No way. And then it's going to read right to left to right now. So 0, 1, 1. I should just be able to switch these around. I'm thinking. Does that make sense? Chunky boy. 0, 1, 1. 0, 0. Oh. What happened? Okay, put it back. Okay, that's ASD. So we're starting with the last one. And then this one. 0, 0. 0, 0, 1. Oh. Oh, it's flipping differently. 0, 0, 1. Right. And then 0, 1, 1. Well, I guess we could just do that. 0, 0, read 6. Okay, now we're here. And then 1001, let's read that next. And then 1011, 1011. Read 4 bits. And then read the last of them. Why not? Read 5 bits. Sure. Sure, whatever. Okay, and then that should be like that. So then this is slightly different. So S, the number S. So this is generating a mask. Reading from the least significant bits, but we're now reading the most significant bits. So the mask needs to be generated differently. Well, okay, so we have a mask that is the length of shift. We just need it to like pad with zeros on the other side, basically. We can actually reverse the bytes. Can you do that? Reverse bits? No, you can't because it's a single byte. Read cache. Okay, if I do this as cache, U8, and then reverse the U8 bytes. Now that will work. No. Okay, so then that is the way that I've made it up. Maybe there's a less convoluted way to do this. It's funny. It's just a test. It's just a test. It's okay. All right. What did you say? It can't think of anything. All right. Oh, alternative. Yeah, it doesn't work. Okay. Test it. It's not gonna work, but BE. None of the tests succeeded. Oh, actually. This would be a bit nicer. A bit. Saying cache bits. Yeah, it just reads zeros if it reads over the end. I could make it optional. Once if you try to read over the end. But then you have to. Oh well, no, they have the cap. Well, this is deleting the cache. Unbounded shift left. Yeah, this just sets the value to 0. Yeah. Yeah, it only loops once. So this is like an if statement. And then you swap this, then write it to that. Game. Oh, I put in a BE. Whoops. I believe it passes the tests. Okay. A little bit nicer. All right, let's look at the BE. What did I do wrong? Oh, this is wrong. I think this is right. So the idea is that we're reading from the top of the bits. So if there's already bits in the value, you want to bump them up so that you can put the next ones on the bottom. And that's what we're doing here. Shifting up to make room for cache bits. And then inserting those cache bits at the bottom. And now there's more bits in the value. And then now we populate the cache for the next loop iteration, which will never happen. And it always gets filled with the full number of bits per chunk. What is this? Lee bytes. Would it go the other way? I have no idea. So we want the first byte to be at the top of the number. So that's BE. In it. Oh. What about this? Is that wrong? But it worked. So it's 0 up to little Indian. That makes sense. We're reading off the top of the number, and we expect the first byte to be there. That's big Indian. So we need to copy this to the other side of the slice. So this is at the bottom of the slice, and we need to copy it to the top of the slice. So this is 0 to 3. Let's say this is 3. Let's say there's 11 bytes, and our cache is 8 bytes at a time. That would mean that the remainder is 3 bytes. So we want to fill these 8 bytes with the first 3 bytes at the top. So that's simple enough. Well, n is this number minus this number. And then BE. Okay, which one's failing? Read bits. I did this. Reverse 8. 1 shift minus 1 reverse. Okay, where is it failing? Left equals right. 69. Oh my god, bro. 164. Oh, I got it. So these are the high bits and they haven't been shifted down. So let's say shift is 5. So now we have 1 1 1 1 1 0 0 0 as the mask here. And we want to shift the final value down by 3. Okay, I'll just do that. 3 minus 8 8 8 0 whatever. I'm gonna shift right by bits minus shift. Okay, we got a BE reader. And the tests indicate that it's working like I expect, which could be wrong or could be right. All right. Fun stuff. Why don't I annotate the test here? Reading bits right to left. That's completely wrong. Yeah. And then Lee from right to left. What? Doesn't get this nice arrow? Oh my god, bro. Cool. Okay, so hell yeah, we got a Lee reader and a B reader. We're reading those B's. You know it. I wanted to like fix this thing a bit more. Oh. Unwrap or default. Yeah. Yeah, this is map or. Except, I need to dereference. I could. Let me write it. See if I like it. Copied. Dot map or default. Sure. So this statement could look like this. And now it's on one line. God, this makes sense. We got the B reader and the Lee reader. All right, let's document. Let's document. Read the slice as if one byte at a time. In order. Bytes are bits are read starting from the least significant bit from each byte. Bits are read from each byte. No way. Read from each byte, starting from the most significant bit. Actually, this is not, well, BitReader MSB. Is this BE? Well, yeah, it is, because it's the, well, it's not really endianness. You're just either reading from the most significant bit or least significant bit. BitReader MSB downwards. BitReader LSB upwards. I think BELE kind of just makes intuitive sense. Programmers know about endianness. And then we have a little documentation here. Read bits from the slice in order. Bits are read from each byte, starting from the most significant bit. It really is bits are read as if from each byte. But then the real implementation is using these chunky boys. Chunky chunks. Do we like this? Sure is rusty. Next copy map. Let's see. Wow. Sure is on one line. It does make it clear that you're replacing cache on every loop iteration. And like, look at how nice and yeah, I think I like it. It's a little bit gooby, but structs Boom, boom, boom. Oh! Um. Uh. Cache one-liner. Okay. Let's go. We got a BE bit reader. Read those bits BE. I don't even know if this is the right way around. Right way around. Round. Let's look in the for the Actually, I'm going to say that out loud. Let's look for end array chunks on crates.io. Adds array chunks back in. Array chunks are back on the menu. What the hell is pervasive? Oh god. Alright. Nice one, dude. Okay. Cool. Bah. How else? How does this go? Neat. This is like... Alright. This is beautiful. This is not very beautiful, but this is beautiful. I'm curious. Dude. Please. Alright, I give up. Okay, so we have BE. What does that mean? That means is this doable? Can this be adapted to the read trait? Because it's not using the read trait. It requires all of the bytes to be present. Which is certainly something. You got bytes, you need bits. But do you really got bytes? I'm sure there's bit readers for read trait. This one, this one's for me. All right, but what about bit write? I only really need to read at the moment. I did want to see about writing. I could implement bit counter from BitWriter. The count starts at 0 and it goes up. Why don't I document that? Bit counter. Bit count starts at 0 and goes up when reading. Bit count starts at the read limit and goes down when reading. No way. New reader. Problem with writer is we're gonna like write to a vec or something, and so you want like extend trait or something. I wonder if I could make a write trait adapter. BitReader. So imagine two backends. You have writer trait and VEC as backing stores for BitReader. And then there's some sort of trait like write cache, where like the only purpose of the trait is that you can write this cache value. It's like pushing a usize into a VEC kind of deal. And like that's it. And then VEC implements cache write, and write trait implements cache write. Let's see what it turns into. Oh my god. Hmm. Save. Oh no. Bit right. Oof, okay. So cache right. I just want to see where it goes. New branch. So it's like the same thing but sucky. Oh my god, bro. And then yeah, it's probably good. Okay, well, I have to do things. Cache right. So you have a bit reader that reads from bytes always. Or we could have a conversion interface that converts into this ish. Chunks, we more want a chunks iterator. Fallible iterator. Okay, just try right. Um so you super one lib one and writer Lee no, and then we go impl cha for vec type cache equals cache, type output equals self dot okay, and then W right. Wayment. Is this going to conflict? How do you... Oh, it's an IO error. There is none. It's always IO. Help. How do you... Hi. Result. IO result. Always. Result. Boom. And then... Yeah. Conflicting implementations. That's what I thought. Okay, so this... But this... Okay, I get it. Interesting. Meh. So in order to have a blanket impl, you have to throw away vec implements the right trick. Is it always like that? If I go like, oh, I have this type called struct, whoa, and it's a vec. Oh no, it likes it. Okay. Oh god, do I need like rightly? No, because they would have different bit right implementations. The Lee. So bitrate would call cache right. Yeah, right is like kind of sussy. It's kind of tricky. All right, just thought I'd check it out. Cool. Yeah. Counted. So you should just be able to do counted bit reader Lee new, and it'll just do it. Love me a bit counter. Count those bits. You know it. Trying to go small. All right. Gotta frick the license into it. Copy. Anything else, brother? Change log. Ooh. Okay. All right. Bitstream. What is up? Welcome to the Bitstream crate. Let's go. Oh. Yeah. Bitstream. Currently, is a collection of adapters for reading and writing bits. Collection of low level. I feel like every program in their dog has written this, but mine's better. Alright, how did the thing do the thing in the thing? Okay, let me say that actually out loud. How did the Roblox mesh code test the README code. I'm trying to like train my brain to be able to actually create mental connections rather than just say literally nothing. Okay. Oh. Believe it's right here. No? Alright. Insane. Alright. New. SDF. Oh, right. You don't need to do that. Why don't we copy the Lee test here? I don't think you're allowed to do this. Maybe if I do as you ate as char. We could just do this for both sides. So then let's get those biddies for F. Give me the biddies. So we're reading from the little endian. So read 332. Or 323. Come on, bro. All right. So then BE. Oh my god, bruh. So then it reads from here. We could just ignore this for now. True. So true. Very true. This is why we test the tests. BitRead. Here's what I'm gonna do. I'm gonna keep grooving. Can't stop. This is read BE. There you go, fella. Oh. My, oh my. Forgot this son of a gun. Should I go here or here? Oh my god. Okay. Uh, mm. Is this? So like, yeah, no, that does make sense. I like that. Cause like, from, new, read, read. It's, jung jung. uh. B, le, la. Okay, read me. Okay. Making libraries is fun. Uh, uh, currently includes what? No way. Uh, let me think. Does does the name make sense? Little Endian. Read least significant bit first. I could do more examples. Is it obvious? If I look at this, bit counter new reader bytes. It just makes a thing. Looks good to me. None of bits, none of bytes. Right, you probably want to implement the error trait. Right, give me error trait. Give to me. Thank you kindly. All right. What happens if you do no STD? What do we need here? Yeah, it's just the bit counter and this thing that I added. I don't think these are available though. Oh, they are. Oh, let's go. We got no STD. Ha. Typo. Error trait. We happen to be no STD. Okay, let's look at the from the let's look at the cargo toml stuff from the Roblox mesh. All right, so we're adding boom, bit stream, yes. It does something simple. Hello. Read and write bits. No. Keywords, bit, reader, bits. I don't know. What kind of stuff? It doesn't have a writer. Read bits. Dependencies, not at all. No. Inform, create, package. Fill in package details. Maybe read bits. Bits bit reader. You can read, but you can't write. Reading. Is intended to be a collection of syncing. Are you syncing? Okay, so then what about I lost my train of thought. Yes, read from reader. That's a self-referential data structure that I just created in my mind. Like, these could for sure be backed by biddies, but biddies is very efficient. It does all the work up front, and then it's very compact. Yes. So this necessarily means the cache needs to be populated. And if okay, there's like subtle logic here for how the cache ends up if we exit the read operation. So imagine this is optional, and I just go like, whoop, question mark. I guess like this. And then this is dot map. No, well, no, from Lee, yeah. So that would go like this. Oh. So what happens here? Well, it goes chunks next, boom, copied. Oh no! And it exits. But cache still has the old value. It hasn't been cleared. So does cache bits. So it didn't actually steal the value out of the cache and put it into this value here. It didn't empty the cache. So that's why I'm like kind of like reading zeros at the end. But if I had a little replace guy going on, or like yoinky sploinky, it has to not question mark. Like right after it reads next, it must clear the cache. Well, no, that's okay actually because, well, okay, yeah, no, it depends on what you want. Like read, if you try to read bits, and does it move the head if there's not enough room, or does it not move the head if there's not enough room? Like it's kind of like there's two valid behaviors here. Where like if you read past the end, do you consume what you tried to read? I guess what's like the behavior of IO reader? Just thinking, thinking. I'm thinking. Uh, uh, yeah, add that to the thing. Which one's, I forget which one's more popular. There's no STD. Okay. Uh, categories. No standard library. Okay, so this, does it mean no underscore STD? Does it just know it and it figures it out? Nobody knows. Okay, that one has underscore as well. I'm going underscore. Read bits. You know you want to. Alright, I don't actually know if I need this, so I am going to see what's up. So music has been kind of fired. Yeah. That's what I think. That's what I thought. That's what I'm saying. Dependencies. Just been RW. New. I saw an article that said like publishing and distributing don't need to be at the same time and tied together. You could have a default like 1 week delay or something, so that, because like the idea is like, oh well, if you immediately have the new version, maybe there's bugs, maybe there's security vulnerabilities, maybe people will find things. So if I stay back, then everyone else can be my beta testers. But now that's like on the client side, the like package manager side. Now every individual package manager has to implement that. And then like everyone does it differently, everyone makes it up. So why not do that, have that option on the package distribution side, where there's an index of published packages and released packages, and you by default grab the released package, but you can opt in for early access and opt in to be a beta tester, rather than like anyone who doesn't think to delay their packages is a beta tester unwittingly. I thought that was an interesting idea. It's a good solution if you consider delaying package updates to be a good solution. You just don't write bugs, right? All right, we got those itty bitties. Okay, so we're gonna take on a no dependency. Oof. Oh, hello. Cargo add bit stream path dot get bit stream optional. I'll probably use the bit stream for my tray decoder thing as well. Alright. You know what? Before let's go look at this a sec. Yep, we're gonna look at. That's the wrong one. This guy. Ask the AI. Hey AI. Is there a way to do this safe? Or more like, is there a standard library function to do this? Is there a standard? Have fun with that. Okay. So now let's write up. Whoa. So now this is delete. And then oh, BE. And then uh-oh. This is why you dog food. The freaking error wasn't there. Okay, what is up with this? Why is it doing that? Okay. Hello, error. Is there stuff? There's you and no other stuff. Let's try that. What did AI say? Server responded error. Oh. Woo. Woo. Oh, that's probably why the thing went black, isn't it? Whoops. Fix missing error. The There you go, bud. All right, and then yep, you come back. I want this over here. Error. Wow. And then it 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 eh uh 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 Okay. Bit counter error symbol. Ooh. We can just smag dab it. Crap. Yeah. Okay, and that's not real. Help. Do it. So this is the only error. Oh, and not real. Edge breaker error is widowy just bit counter error. Oh. Question mark. No way, bruh. Not real. Failed. Okay. We probably also want clone. Um. All right, let's do that for the other structs as well. Debug clone. Oh. Good. Good. But not copy, even though it's pretty small, because you want it to be explicit. Like this guy. Wait, what? Clone. Okay. Good one. Boom, boom, boom. Uh, okay, so it is different, and I need to do it the other way around. Let's do BE bytes. And then now we can actually do this. Forwards order. Alright, continue. And then 101. So it reads this bit and then reads 01. So that's left. Most true is left. Okay, we'll just make it up as we go. 0, 001. So that's continue. Okay, well this was this is now 100. 101. 110. Okay, so then hello. So this is continue, and then 100 is split, and then 101 is left again, and then 111 is end, and then 0 is continue. Wow. So actually I could pop it, lock it, drop it like this. Go Lee and do what up here. And then now this passes the tests and that passes the tests. Oh. Oh, no. Okay. Checkout comment. Check this out. It passes the symbols tests. Not the principles. And then this also passes the symbols tests. Huh? Didn't it just work? Continue. BE bytes. 101 is left. 0. 100. 100 split. 101 is left. We already saw that. Why don't we switch this to 10? Actually, this one was supposed to be 10. All right, where's it failing? 42. If I say this, yeah, okay. One extra bit is too much. Just checking. Big endian, wait. Big endian means this big byte goes first. Show me the money. What if I do this? Can I say this? No. Bro, show me the... Something wrong. What? Why it not work? Why it not work? Is it the library? I don't know. It's supposed to work. Okay, I didn't really test this. I tested this. Yeah, dude. This worked. So what is up? What the hell? 0-0, man. Come on, man. Come on, bro. This is the other way around now, but I will have to see. Surprising amount of soundstage. I'm not 100% sure it's AI, but like, there's some parts of the songs where like a guitar turns into a voice, and like the artist published the tracks in multiple places, and they were just like straight up sped up on some bits, like unaltered sped up. So like, yeah, I think it's Suno AI. Notably, there's another channel that I was listening to that I'm pretty sure is the same AI, and it like had the same kind of like creative patterns. Like it same flow, to the point where it was like, oh, I've kind of already heard this before. It's a bit boring. Which is, that might just be like, I want it to be like that and I'm making it up. I want AI to fail, but it's good. I really like the music. Keep it far away from vocals. Yeah, there's one song that has vocals in it. I removed it, I think. This one we're on is my favorite album, number 2. This is an OGG file because I downloaded it from YouTube because I like that version better than the album version. But the problem is the songs immediately jump over, so I can't like split it into different files. So I actually created a Q sheet, a Q file that has the timestamps in it, and because this is a continuous player where like uninterrupted, where like it immediately goes to the next song, and it can read the Q files. It's all like, you can actually see which track it's on, and everything's nice. The video, the YouTube video has the wrong timestamps. I had to timestamp the whole thing myself, and like it's like really precise at times. The one song ends, the other one starts, but like I really like the music. Why are the flags 44.1 kilohertz? Opus is 48K. That's because YouTube. Also, Opus, the codec, only supports 48 kilohertz. 44.1 kilohertz is like the standard, and Opus just breaks the standard. A1 forked opus. For a new codec. Wait. I could use the bitread trait here. Wait. Oh no, I made it too flexible. Bitread output. It could be anything read. Except it says bits. Output. Just have like trait anything. Just have like a tuple and put like God knows what. Oh. Read input output. Input. It's just literally the anything. Oh. Yeah. I don't understand. Why is it broken? Huh? Is huh? Come on, man. Let's see. Maybe it's just hitting like a rare case. Rare. Boom. Ba ba boom. Ba 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 boom. Alright, so I can just read it off. Alright, yoink, sploink. Okay, 1 1 3 1 3 3 3 1 0. Okay. Oh my god. Oh my god. Okay, so 3 is 1 1 0. And then 1 0 0. And then 1 0 1. And then 1 1 1. Come on, bruh. Okay, let's try splitting it up. 2 1. What? What is going on? It is reading exactly what I expect. So where's my mistake? Zero, zero. Like, I just have no idea. 42. So the first one is 0. And like the test that I just deleted, 0, 0. Huh? What's up? Yeah. So read 0, 0 is the same thing as what I'm doing over here. Read 0, 0. Huh? 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 It's the wait, what's this? This there's no problem. It's nothing. It is the exact same code. Call read 1. Call read 1. Read 1 and then it returns and then read 1 and then it does something else. Like, is it trolling me? Is there something that's like changed somewhere somehow that's I'm seeing 1 equals 2 here. So this test, read symbols, has this number here, which is the exact same number as right here, which is 2 BE bytes. We make a BE bit. Oh my god, bro. What is that? What is that doing there? Capital letters, please write capital letters. Well, there's your 1 equals 2 problem. Jesus Christ. All right, let me try that one again. Okay, so I just did a rebase and it like forgot what I did because it was Git. So Git trolled me here, but it's my fault because I didn't realize that it would do that. because I'm dumb. Stupid. Okay. So there is the big Endian symbol reader. And then this still doesn't work because, of course, it doesn't. But now it's different. I don't know if this is gonna work. Am I gonna need some like idiot reader? Like, basically, is Roblox stupid is the question. Did they make a mistake in the implementation and they just have to stick with it in the file format now? You never know with Roblox. With anything else, I would say, oh, probably they did the best they could, but hasn't been the case with Roblox, like, ever. Like, look at these file formats. Disgusting. Okay. So let's go to the snap thing. I'm going to make this a branch called... BitReader BE. This is spent 3.5 hours making that thing. Time of my life. Oh. What's up with this? Yeah, okay. It works. So what I could do in the design here is this could be an option and imply this error. It's not that it's good to name things though. It's not really an enum. There's only one thing that can happen. Oh, this fails before it moves. It makes sense. It can be like that. So like, imagine there's 9 bytes total. You read 7 bytes, and then you try to read 4 bytes. It'll just not move. It'll throw you an error. And if you handle the error and then come back and try to read 2 bytes, it'll let you do it with this code. And I think that's okay. It knows there's not enough. Oh. Shareholders Nod. Super good song. One of, like, maybe even the best song. Has impeccable timing for like when to transition to the next stage of the song. Knows it's got it good. Okay, I have to write. Do you collect music physically like CDs? No, I'm a digital nomad, digital collector. Oh, it's not reverse order. Come on, bro. Oh, that. Okay. Right. Okay, so I'm thinking about um like matching against error variants and knowing which errors are possible. So like if you look in this, it's possible for it to return an error, but there's only one variant in this function. So it's both convenient to have this in a unified error so that you can question mark. You see that this actually reduces the number of lines of in here the number of lines of code is reduced here because it's all one error. But because there's only one per function, you could actually like ignore the error, map out the error. You could just say .ok, and then now it's an option. I think this is the best way to do it. I was considering whether I should make each of these variants into their own struct and then return just like this as like a struct like this. And then now they're different errors. But I think this current implementation is optimal. No way. Mm-hmm. Optimal UX. They have lossless on them. So does FLAC. So does downloading FLAC. Okay, whew. It does that. That was infuriating. But I must get past it. Continue. Try the snapper dapper. Gonna get a yellow babber. So then this code, we won't create branch symbol buffer 2. And then what do we cherry pick the comments, and then snapper again, nor symbol bitty county error help mod odds, and then not for real. Sorry, I was just talking about ass. Okay, looking good. Let's accept those changes. Cargo insta review. And then, holy. So, decode and snapshot. And then, it looks good. Looks good. Come on. Be the same. Please be the same. Oh. No, it is. Not the same. This is a tragedy. No. Well, yes. So it's no longer independent of the cache size. I might still be able to get away with having a library though. I'm thinking it's like big endian cache, little endian bit reading. So it's like instead of going through the bits like this, bit, it goes like this. Bit, and there's like chunks of 32 bits, and they just implemented it stupidly. But such is life. Now the question becomes, how do you implement a bit reader so that it can be little endian, big endian, value from the top, value from the bottom, any of those four. There's 2 properties, 4 variants. So I have 2 variants right now, and then also generic across the cache size. Like, it's just kind of dumb though. Instead of like these actually make sense. Like, both of these are reading through the bits forwards, but one of them treats the bytes as the top is first, and one of them treats the bytes as the bottom is first. But they're both going through bytes in the same order, like first byte, second byte, third byte, fourth byte. But the way Roblox is doing it is they're going through the bytes in a stupid order. It's mix and match code here. So I believe what is going on? Who did this? Okay, just do it. What do you want? All right, see ya. So what we can do is make let's make the Roblox reader. I guess this is a trait. Like, yeah, read. New BE. You'd want to have it type state. Yeah, I'm thinking unify the objects. Oh, you can't use enums? No. All right, let me make BitReader Roblox here. Because that's what we have. So cache is not real. Lib. Type cache equals u32. And then Roblox. And then it's either the Lee BitReader with a B bytes, or it's a B BitReader with a Lee bytes. Let's try this one first. I'm still hoping that it's not just fully bespoke nonsense. Right. Oh my god, bro. Okay. Yeah, dude. All right, go for it. Yeah, like who even knows? Like, it's gonna fail the test, but like, maybe it's right. All right, so we're looking at this versus this. I think it's gonna be wrong. Ooh. It's right. Let's try the other way around and see what happens. It's one yes. So if I just replace all of the B code with Lee code, oh, it won't pass any tests, that's for sure. And then do this B. What happens? So, yeah, let's try again. Test. It'll be different. No, it's different all throughout. So then this versus this. Yeah, no, it's so this one you can see it's only different at the end. Like, this is just the dumbest thing I've ever seen. Yeah. Someone had no idea what they were doing when they were making this. It's very sad to see. Wrong people on the job. So you see it ends with this end instruction. I believe that is correct. I really don't want to implement this. It's dumb. God, I made a whole nice library and then they just do it asinine. It hurts my feelings how poorly it's implemented. Disrespectful to the original designers of the algorithm so many years ago. Just implement it so poorly. Well, at least I got the sequence to be the same. This is bespoke. This is exactly what I didn't want. So I wrote this library and it's not applicable because it's completely bespoke. Okay, well, let's rip it out. Rip off the Band-Aid. So I'm gonna need to make up some trash. I'm gonna call it bespoke BitReader. Actually, no, it's better. You good? Okay, what happened? Hello? Okay. So I could just switch back to array chunks now because there's no escaping the idiotic way it's implemented. So just have to make do. I am gonna copy this file. Thank you. I could still use my library and like use the bit counter and the bit read trait, but it's not worth it at that point. It's so bespoke. I'm getting added. Yeah, let's go no trait. Uh-huh. We won't need this because, okay. I'll just switch everything back to the stupid way. Back when everything was stupid. Cool. Yeah. Freaking like that. Okay. Great pain. Okay, so that's not real. What's going on here? Yeah, that's not real. Just call it read. It's read some stupid thing. Match. Alright, Sitcom Life. This is another contender for the best song in the series. Thundering, rumbling soundstage. What is up with this? Oh, cache equals. Rem length. True, true. Do 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 do. Mm-hmm. There we go. So we have to use the stupid idiot 56 bytes instead of the clean 32 bytes. Struct. Why did Roblox do it all wrong? Alright. I think I implemented it. No traits. Okay. Does it behave the same? SoundCloud recently moved to Opus. Removed Opus. Oh, I was gonna say no. They've been in Opus for a long time. Removed Opus and replaced it with nothing. I mean, if you like using twice as much bandwidth, I guess. HLS AAC. Is it at least HE I know there's a few newer revisions of that are pretty close to Opus. Okay, let's try symbol buffer 4. Okay, so we'll see. We'll see. Okay, so this is the correct one, and we are not even close. Didn't I? What? Didn't I paste it in and it was like correct? Which is this one, right? Oh, it's 2. Okay. So I tried full flipping it. It was the big onion. I don't remember. Did I just paste the exact wrong one? Okay, I think I just pasted the exact wrong one. I don't freaking remember. Let me look at the code over here. This one was confused. Okay, so I overwrote. I don't remember if it was right or not. You know what I can do though is I can go and go back to that comment. Roblox, and we can you know. So maybe that was 2. Let's see. Read symbols 840. Help. Test 40. Yeah. Okay, so we're failing here. Okay, so it is exactly this snapshot. So I copied the wrong one, man. Oh God. Okay. Let's look at the diff. It's really nice that they're in separate projects here. Okay, so we want Lee. And we want this type situation. And we want some other crap. This code here. And this code here. Let's look at the diff stream. So Lee, not Lee. So it's here, and that's pretty much it. Oh my God, bro. Oh my God, bro. Really, dude? All right. Send it. Oh crap. Number 5. Okay, did we get closer? Yes. Okay. So now I just need to fix the end here. So this is currently correct, but we need to do it the wrong way, like Roblox. So let's try BE and see what happens. Did that not change the... Well, let me look at the reference code here. We need to wait for these to open, and then we need to wait like 20 seconds for closing it. GitHub. Microsoft. Close, collapse files. It's a really complex operation, you know? All right. Have you tried song requests? You could provide more entertainment for us. Unfortunately, that's not really the point of the stream. The point of the stream is to keep me focused and on task. Okay, so this says that MSB first across full words, but LSB aligned in the last partial word. So, according to this, it is always... four-byte aligned. This is the dumbest thing. Crawl in a hole. Have the VODs ever been useful to rewatch and understand the old thought process? No, not really. I'm realizing that I've never really taken advantage of having so much of the history available. I have local copies as well. It'll be useful to train my AI replacement. That's about it. report your stream will become the most viewed. That was not fun. That was not a fun time. My neck still has a little kink in it, but it's just nothing compared to that. Why are they doing div seal here? Should be multiply on the other side. Like, I guess the compiler is gonna turn it into a multiply anyways, but. Yeah, I'm not really sure what to do for this. I think that this case doesn't exist. Um, God, did I? Oh my God. What? Oh. Okay, so that has nothing to do with it. This case is never reached. Here's what I'm gonna do. Jeez. There we go. Okay. You good, bro? And then oh god, this is gonna not be fun. It's just gonna not work. Oh, true. um, okay, so wait, what? Oh, I did it wrong. God damn it. Is it called that? Am I stupid? Am I stupid? Yes. And then I can't grab this. So it'll frick on me. Okay, and then we try this again. Let's revert all the comments. Let's try this again. Okay, does it diff this? Yes, we finally get the freaking diff. Okay, we don't get any tests because we can't have nice things. See, where is it? Oh, it's just here. Whatever. Okay, so there is the madness. Wait. Almost. There's only one new file. Alright, and then when we run this, it all fails because it doesn't work. Yeah. Okay, and then I have no idea what this is gonna do, but I can just compare it to the other thing. This is partially. Okay. Delete A. Drop stash. So we're trying to match this symbol buffer. Actually, why don't we just cherry pick this, and that'll help a lot. Reference symbol buffer. Delete this. Well, that is very sad that Roblox has a stupid implementation. That doesn't make sense. It does mean that the library doesn't get my new dependency thing here, but it also means like I'm probably gonna keep it private on StrafesNet crates repository and use it for old bot decoder probably, because those ones do make sense. Trey actually used his brain when he was making it. Used his brain. Thought about it and built something sensible. God, I was gonna make it all nice and then nah. I'm just gonna screw it up. Why is this not formatted? Interesting that it's minus. Oh, it's the tests, right. What else can I do? It did get nicer. Working on a library was beneficial. All right. Read bytes in an asinine manner. Amazing. Inconsistent. There we go. Bits. Inconsistent manner in the same inconsistent manner as Roblox. How is the Roblox thing going? Radio silence. Roblox has not responded to anything. Let's go. Surf remains down. Let's just make sure I didn't mess it up. Yeah, looks right. Nice. Amazing. So now all I need to do is figure out how to do the end of the buffer and can I actually mutate that? No, that'd be a bad idea. I made a whole library and then I can't use it. No. Okay, where's the thing, the pull request? This one. Oh, I'm pushing the wrong branch. Oh no, I'm not pushing the wrong branch. Ay 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 ay. Well, I did partially figure out Roblox's madness. I will need to fix that. End of the thing. Is it, what is it? So looking at this, LSB align, MSB first across forwards. So like the bits are at the bottom. So you're, okay. Maybe I should just hard code it then and like populate the cache, read off the bits. How do you do that? How do you write the encoder like that? I guess you're pushing from the LSB. I don't know, man. Dividend. 7-minute song. I really feel like leaving this for tomorrow. Roblox's shenanigans have drained me. 5 hours. Oh no, it's 6 hours. 6 hours is nothing to scoff at. I'm recreating a good portion of the the reference buffer. There's a good chance that I didn't make any other mistakes. The bit reading is really the most bit twiddly fiddly stuff. The rest of it was just like copy pasting, but like creating the bit reader was an original work. I just did it wrong. It's easy to do it wrong. Yeah, I didn't want to copy this bit reader. I wanted to do a bit reader. So how are we looking in terms of the codes? I guess we can go like this. Branch, mesh branch, one fetch, branch, work branch. So plus 500 lines of code. Which it already was 500 lines of code. There is no writing. Ugh. It's nice to work through this myself. I still don't understand the edge breaker algorithm, but I've kind of given up on that. I might just make my own instead. If I ever want to compress meshes like this. It's pretty cool. Less than 1 bit per triangle. I think these both have to be like this. This is AI music. Strafe client will save everyone. It's hard. Alright. I think I'm gonna end the stream. Edge breaker algorithm. Yeah, I've almost reproduced the buffer thing. It's good. Getting closer, making progress towards having an implementation. All right. See you tomorrow. Bye.